Thank you, everyone, for joining us at Griffith Observatory for a live broadcast of the southernmost moon. I'm Dr. Ed Krupp, Director of Griffith Observatory, and this cheering astronomical event is brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks. The sun set in the northwest here at about 8:08 p.m. Pacific Daylight Time. It's still civil twilight in Los Angeles, and the full moon will officially rise in the southeast at about 8:28 p.m. Pacific Daylight Time. But that moon will be a little bit delayed by the hills to the southeast and also by the haze. Now, the moon is doing something it hasn't done for more than 18 years. Its orbit around the Earth is now tilted at the greatest angle outside the path of the sun. That sphere represents the sky above and below the Earth, and the white disks in the image are the moon, and the circle on which those disks are located is the moon's orbit. It is tilted by a small angle, as you can see, to the other circle, which is the path of the sun in the sky, or really the reflection of the Earth's path around the sun. Well, we'll see what is causing this, of course, and also what it does on the ground each month for the next year and a half in the positions of the most northern and southern moonrises and moonsets. The greatest excursions of moonset are marked on Griffith Observatory's lower west terrace. And the last time this happened was in 2005. In fact, that's a picture of 2005 with the northernmost moon setting along what is going to be, or was going to be, that moon line back then when we were under construction. Between now and December or so of 2025, the moon will each month rise and set as far north and as far south as it ever can. And the period in which this happens is called the Major Lunar Standstill. And you can see the monthly limits of the moon carry it beyond the position of the sun, either in winter or in summer. Now, the moon doesn't really stand still. Its monthly excursions just reach roughly the same maximum limits each month for about 2 years. As you can see, of course, though, the sun does something similar, but it does it over the course of a year, not like the moon over 18.61 years. Every June, the sun rises and sets as far to the north as we ever see it, and 6 months later, in December, it rises and sets at its southernmost limit. To the unaided eye, the position of sunrise and sunset at these times of year does not seem to change for about 3 days. The sunrise and sunset seem to stand still, and the time when this happens is called a solstice, which means sun still. The moon's a lot more complicated than the sun. Each month it travels from north to south and back again, but from month to month, the northern and southern limits of moonrise and moonset change. The sun's limits from year to year, on the other hand, are the same. So the moon does in a month what the sun does in a year. It moves from north to south and back again. Each month, however, the moon's limits gradually change in a cycle that takes those 18.61 years to complete. During that time, the moon's limits move from outside the sun's limits to inside the sun's limits, and then back outside the sun's limits again. And we've marked these limits on the lower west terrace of Griffith Observatory. The northern inner and outer limits flank the summer solstice line that points then to the northwest. And on the other side of that terrace, the southern and inner limits flank the winter solstice sunset line that points to the southwest. But in this view, you're seeing the sunset line to the north. Well, when the moon rises and moonsets reach these limits, the limits don't seem to change much from month to month. There are 2 periods when that happens. One at the moon's inner limits, and one at the moon's outer limits a half a cycle later. These periods are called the standstills, and they last about 2 years. The moon's limits still change through this period, but the change from month to month is small, just as the change of the sun's positions at the solstice is small. Well, we're now in the season of major standstill, the time when the moon's monthly limits are far outside the sun's annual limits, and the extreme moonrises and moonsets are farther north and farther south than the solstice sunrises and sunsets. In another 9.3 years, the limits for the moonrises and moonsets will be inside those solstice points and will be at the minor standstill. The monthly limits then will gradually increase again, and in 2042, we'll have the next major standstill. So mark it on your calendar. Now, the moon behaves this way for two reasons. First, the moon's orbit is tilted a bit compared to the Earth's orbit around the sun, as the diagram makes clear here, a small angle, about 5 degrees. Second, thanks to the gravitational pull of the sun, the moon's orbit swivels, it rotates, and that changes the angle of lunar excursion and the amount of the moon's reach, and it turns completely around in 18.61 years. Although varying limits of moonrise and moonset are noticeable over time, most people, including professional astronomers, have no experience with this aspect of the moon. You have to track the moon systematically, month after month, for several years to realize the moon is doing this, and you would have to track it for several 18.61-year cycles to see and understand the full pattern. Despite the difficulty in mastering the lunar standstills, some investigations of archaeological monuments, particularly Stonehenge, have led some investigators to propose that lunar standstill alignments were designed into some ancient and prehistoric sites. In the 1960s, C.A. Newham and astronomer Gerald S. Hawkins independently identified lunar standstill alignments in the Station Stones rectangle at Stonehenge, which is part of the plot of this plan of Stonehenge. And of course, this rectangle of stones was constructed perhaps 4,500 years ago. Hawkins also proposed sight lines between certain gaps in pairs of archways formed by the large sarsen stones erected maybe 500 years later. And in fact, this is a view through one of those gaps. This is for the Major Lunar Standstill, the northern moonset. Now, Stonehenge was not the first prehistoric monument that was assigned a major lunar standstill alignment. In 1908, British naval officer Boyle Somerville published a major standstill northern moonrise for Callanish stones in Scotland's Outer Hebrides. In the 1980s, however, Gerald and Margaret Ponting favored the low southern moon, just crossing above the horizon barely through the stones, and this is their picture taken several decades ago. The late Aubrey Burrell was the leading expert on prehistoric megalithic rings, and he identified major standstill southern alignments with the recumbent stone rings in northeast Scotland. This is Castle Fraser in that part of Scotland, and here's the plan of those stones with the alignment cutting across the big stone that's lying horizontally on the ground. Jack Eddy, a solar astronomer, spotlighted a major standstill northern moonrise on the axis of the prehistoric Hopewell Circle and Octagon Mounds at Newark, Ohio, and an ancestral Pueblo Great House, about 1,000 years old, at Chimney Rock National Monument near Pagosa Springs, Colorado, accompanies the restricted view of the major standstill northern moonrise framed by the distinctive rock pillars. Deliberate inclusion of lunar alignments in ancient and prehistoric monuments has not, however, been proved and remains questionable. Griffith Observatory, on the other hand, possesses intentional lunar alignments throughout the rest of the 2024 and most of 2025. Griffith Observatory will broadcast selected moonrises and moonsets at the moon's maximum excursion. We are now about to witness live the major standstill southern moonrise from the observatory's south promenade overlooking a moonrise line installed in the southeast loading zone and headed southeast over Elysian Park, Santiago Peak, and on to Palomar Mountain. The moon may be standing still, but Griffith Observatory never stops moving. As we wait for the moon to rise, some of Griffith Observatory's celebrated soundtracks for the shows in the Samuel Ocean Planetarium will provide the background.
And ladies and gentlemen, thank you very much for joining us for our special broadcast of the Southern Lunar Standstill. We just saw the moon rise at 8:28. It was beautiful. The moon is now continuing its upward path over the Los Angeles skyline. It will attain a maximum altitude at 1:12 a.m. Tomorrow of 27 degrees above the southern horizon. That is the lowest altitude for the moon as seen from Los Angeles at this southern lunar standstill. At this time, thank you very much for joining us and witnessing this special event here at Griffith Observatory. This broadcast was brought to you by the City of Los Angeles, Department of Recreation and Parks, and of course made possible by the Griffith Observatory Foundation. Thank you, and we're going to go ahead and conclude this broadcast for this evening. Thank you very much. Good night.